All right, so for our notes this week, we are going to offer you the option to fill them out on a Google document. So you should have clicked the fillable notes link to create a copy. And once you do that, it's your copy, so you can edit it and do what you want with it. So as I go through the notes video this week, I am going to just type it just like you would have to if you choose to use the fillable notes. And then at the end, there is going to be an activity that I give you directions for right after you watch the notes. So make sure that you watch all the way through this video. So one tip that you can use is if you have your video open and your notes open and you want to see them side by side, if you hover over your tab in Chrome and click on it and then pull it out, it creates a second window. And so when you do that, now you can resize your window. So I can make my video about half my screen, and then I can also make my notes about half the screen. So that way I can have my notes on one side and the video on the other. And then as you are watching the video, you can watch, but you can also type in your notes, okay? So I just wanted to show that to you before we start. So now that we're actually going to begin, hopefully your notes are all set up, we are learning about the definition of probability this week. So probability is of an event is the measure of the likelihood that an event will occur. It can be measured between 0 and 1 and displayed as either a fraction, a decimal, or a percent. So this number line shows you how probability is going to be seen. You're either going to have somewhere between 0 or 0%, all the way up to 1 or 100%. Remember that 1 whole is equal to 100%. So you could have 50% or 1/2 or 5/10. So if you get a probability that is 0%, that is going to be an impossible event. So you could describe that as being impossible. Something that would be 100% is going to be a certain event. It's definitely going to happen. If you get 50% or half of a probability, then it is neither likely nor unlikely. So it's equally likely, equally unlikely, because it's right in the middle there. But then if you consider the range between 0 and 50%, that's typically going to just be considered unlikely, but that range between 50 and 100 would be considered likely. So although we will be calculating those exact probabilities, these are other ways that you can describe the certainty or likelihood of an event occurring. The notation that's involved here is the probability of an event. So you see it as P and then parentheses and whatever you're trying to find the probability of. So you would read it as probability of event, and the way you find it is to figure out the number of favorable outcomes, so what you want to happen, what's in the parentheses, out of all the possible outcomes. So we're going to do a couple examples to describe what we mean there. In the first example, it says a bag contains 5 red marbles, 3 blue marbles, and 2 yellow marbles. 1 marble is selected at random. Find the probability of each outcome. So in total, we have 10 marbles in our bag. So those are the number of possible outcomes, because if I reach into the bag and I take 1 marble out, I have 10 possible marbles that I could pick. But right now, in this first example, I want to find the probability of drawing a yellow marble. Well, in my bag, if I reach in and I take a marble out, I could take out 1 yellow marble or a second yellow marble. There's 2 available out of the total 10. So I can say that 2 out of 10 is the probability. But that's not a totally simplified fraction, so we would want to write it as 1/5. But that can also be written as a decimal, as 2/10, or change your decimal to a percentage and say 20%. So those are all the ways you would want to say it. I would, if you're going to write it in fractions, stick with this simplified version. If it helps you to write out the original to see the numbers, that's fine, but make sure you simplify it then. So then in our next example, the probability of grabbing a blue or a yellow marble. So for blue or yellow, a little bit bigger to see that. So for blue or yellow, you can get 1, 2, 3, 4, 5 of those out of our total 10. And again, 5/10 isn't totally simplified. That simplifies to 1/2, and that would be equal to 5/10 or 50%. So if you want to pause the video here and try those other two, just to give them a try before you are checking your answers. All right, hopefully you pause the video to check. Next one says probability of grabbing a red, a blue, or a yellow. Well, that's every color in our bag, so I'm going to get at least one of those no matter what I grab, because those are the only colors that exist. So that would be 10 out of 10, but 10 divided by 10 is just 1, or 1 whole. So our simplified fraction and our simplified decimal form there are just 1, or 100%. And then finally, for the probability of getting a purple marble, well, if I reach in there, there aren't any purple marbles for me to grab. So that would be 0 out of 10, and that becomes 0 or 0% chance. So now you can classify each of these as either being likely, unlikely, certain, impossible. So 20% is going to be somewhere around here on our number line, and that's going to be unlikely. It's not quite impossible, but we can just say that that would be unlikely. 5 out of 10, or 50%, is right there in the middle, so it's neither likely nor unlikely. Or you can say equal chance. Then for 100% chance, that is a certain outcome, so we would call that's definitely going to happen, it's certain. And to say 0% chance, that is impossible. There are no purple marbles in there, so it would be impossible to take one out of the bag. Then in your next example, we are considering if we roll a normal die, so that has 6 sides, numbered 1 through 6, what would the probability be of first rolling a 6? So if you want to pause the video and try all 3 of these on your own, then check your work, go ahead. And then to check your answers for probability of rolling a 6, there's only one side that would be 6, and there are 6 possible sides that my dice could land on. So it would be 1/6. And 1/6 is not able to be simplified any further, so that would be the most simplest form of that fraction. The decimal of that is 0.16, and the 6 repeats. And then to create that into a percentage, we would say 16.6 repeating percent. I don't have the ability to put the repeat bar over it in here, but maybe if you want to bold it to remind yourself that that is a repeating 6. Just a note, if you're working in Google Docs and you want to show how these are repeating, what you can do is highlight the number you're looking for and press Insert Equation, and that's going to create a little blue box for you to use. And what you can do is on this part where it has like little symbols, you pick this one that has an X with a bar over it, and then you can type your 6 or your number that you're trying to use. And then the probability of getting a 1 or a 6 would be 2 possible outcomes that I want out of a total of 6 outcomes that are possible. And that is simplifiable to 1/3. For the decimal form, that becomes 0.3 repeating. Again, I can't show the repeat bar, so I'm going to bold it. And to change that into a percentage, it would be 33.3% repeating. So that decimal is repeating there. Finally, for an even number, well, even numbers that we have available on a die would be 2, 4, and 6. So that's 3 possible answers out of the 6 that we can roll. And that equals 1/2, or 5/10, or 50%. Okay, so those are your answers for those first 2 examples. So if you want to add a reminder for yourself if you are typing these and not writing them and had the same issue I did with the repeat bar, if you want to bold your numbers and then just make a note to yourself as a reminder, bolded numbers are representing those repeating digits, that might be helpful to you when you go back to look at your notes. And then we're going to move on to the next part. So we have some practice problems here. If you want to just pause it and try them on your own and then come back to the video, that's fine. You can do that. In number 1, we have an 8-section spinner, and we're going to determine the probability of each outcome if each of the sections are equally likely to be landed on. We have to write our answers as simplified fractions and percentages. So the probability of getting an even number here, we have 2, 4, 6, and 8 as our even numbers. So that's 4 different numbers that we could land on out of the 8 sections that are available, so 4/8, but that is simplified to 1/2, and as a percentage, that would be 50%. For something greater than 6, the only numbers that are greater than 6 on the spinner are 7 and 8, so that's only 2 possible numbers out of the 8 that are there, and that equals 1/4 when you simplify it, or 25% as a percentage. And then finally, for less than 4, that would be 3, 2, or 1, so that's 3 answers out of 8. That can't be reduced anymore as a fraction, but we can say that it is 37.5%. And then in number 2, it says Abby has 12 friends that want to go with her to Busch Gardens. Her friends are Brian, Greg, Brenda, Gloria, Bill, Sally, Sue, Joe, Cammie, Carl, Jason, and Mike. She places each of their names in a hat and chooses to choose one, and then returns each name after that is drawn. So she's going in, she's reaching for a name, and then she'll write down that person's name, and then she's going to put them back in the hat so that everyone has an equal chance of being chosen here. So she's got all these friends, but she can only take 5. So if she reaches in and tries to just pick one friend, what's the probability that their name will start with a B? Well, she has a total of 12, but only Brian, Brenda, Bill are the 3 names that start with B. So 3 people out of the 12, and that can be simplified to 1/4 or 25%. People that start with a C or an S, so we have Sally, Sue, Cammie, and Carl. So that's 4 friends out of 12, and that's equal to 1/3. Or if you want to write it as a percentage, we would say 33.3%, and again, that 3 is repeating. Same issue, I'm just going to bold it to show that it's repeating. And then finally, name starts with J, B, or M. That would be Brian, Brenda, Bill, Joe, Jason, and Mike. So that's 6 friends out of the 12, or 1/2, which is equal to 50%. And then finally, before we do our activity on our slides, we need to see the difference between theoretical and experimental probability. So what we've been doing here is all theoretical probability. So the theoretical probability is the likelihood of an event occurring when we apply the probability formula, so what we've been doing, or what should occur. Based on what's there, it's what should occur. But the experimental probability is what actually occurs when we conduct an experiment or when we're given data. So the way I want to show you that is by using what you already completed in your Explore. So during your Explore, you should have flipped your coin 20 times and recorded how many you got each. You should have rolled the die 25 times and recorded how many times you landed on each, and then spun the wheel 30 times and tracked how many you landed. So this is my data from when I did this experiment, and I'm using this to help me answer the questions that are on the explain slide. So in number 2, it says, when your notes are done, complete the following tables using what you learned. In this box, it says type the theoretical probability of each event. So if you're just considering on a coin, if you flip it, what's your probability of getting tails? What's your probability of rolling an even number on a die? And what is your probability of landing on a number greater than 7 on a 10-section spinner? Those are going to be using the theoretical probability, what we just did in our notes a bunch of times. This is where it's a little bit different, and you have to use your specific data. So for my data, it says, what would be the probability of getting tails? So in my data, I flipped my coin 20 times, but I only landed on tails 7 times. So it would be 7 out of 20. Rolling a 6-sided die, getting an even number. In my data, an even number, I had 5, 2, and 7. So 5 plus 2 plus 7 is 14 out of the 25 times that I did this. So 14 out of 25. And then finally, a number greater than 7 on the last set of data. So 1 plus 1 plus 4. So that would be 6 out of my 30. And that's the only one here that actually can be simplified, and that becomes 1/5. So now that I know these, and you're going to calculate these because you know how to do it, I'm going to end up comparing them on my slide for apply, and you're going to determine which one was higher. Was the theoretical probability higher, or was the experimental probability higher? The more trials that you end up doing, the closer your experimental probability will become to what it's actually supposed to be, that theoretical probability. So I want you to go in and complete this for your data, see what happened on yours, and then you'll be able to create or write your reflection of what happened in your apply slide. Thanks for watching.